Hello students, you are watching Chemistry Wins YouTube channel. So in this session, we are going to learn about infrared spectroscopy, principal applications of infrared spectroscopy. Infrared spectroscopy is a type of absorption spectroscopy. In the infrared spectroscopy, the test molecules are exposed to infrared radiation and the test molecules absorbs the radiation and they undergo some changes. So here there is absorption of infrared radiation, so it is called as absorption spectroscopy. The interaction between test molecules and infrared radiation will causes vibration of atoms in the test molecule. So if you take test molecule and it is exposed to a particular frequency of infrared radiation, the molecule will receive the energy and the atoms in that molecule will vibrate. So infrared spectroscopy is also called as vibrational spectroscopy. Infrared spectroscopy is an example for absorption spectroscopy, and infrared spectroscopy is also called as vibrational spectroscopy. Okay, so infrared spectroscopy, absorption spectroscopy కి ఎగ్జాంపుల్, ఎప్పుడైతే ఒక టెస్ట్ ఆర్గానిక్ మాలిక్యూల్ ఇన్ఫ్రారెడ్ రేడియేషన్కి ఎక్స్పోజ్ అవుతుందో అప్పుడు ఆ ఆర్గానిక్ మాలిక్యూల్లో ఉండే యాటమ్స్ వైబ్రేట్ అవుతాయి. కాబట్టి ఇన్ఫ్రారెడ్ స్పెక్ట్రోస్కోపీని వైబ్రేషనల్ స్పెక్ట్రోస్కోపీ అని కూడా అనొచ్చు. దెన్ IR spectrum. Infrared radiations are divided into three regions. Infrared they are near IR, middle IR, far IR. Near IR region ranges from 12,500 to 4,000 centimeter inverse. Middle IR region ranges from 4,000 to 667 centimeter inverse. Far IR ranges from 660 to 50 centimeter inverse. Here centimeter inverse is the wave number of IR radiation. Particularly we are interested in the middle IR region, usage of middle IR region. In the IR spectroscopy, the organic molecule is exposed to middle IR region, that is from 4,000 to 667 centimeter inverse, because most of the organic molecules absorbs in that region and shows vibration that results in identification of that particular organic molecule. ఇన్ఫ్రారెడ్ రేడియేషన్స్ని త్రీ రీజియన్స్గా డివైడ్ చేయొచ్చు. నియర్ ఐఆర్, మిడిల్ ఐఆర్, ఫార్ ఐఆర్. నియర్ ఐఆర్ రేంజ్ 12,500 నుంచి 4,000 సెంటీమీటర్ ఇన్వర్స్. మిడిల్ ఐఆర్ 4,000 టు 667 సెంటీమీటర్ ఇన్వర్స్. ఫార్ ఐఆర్ 660 టు 50 సెంటీమీటర్ ఇన్వర్స్. మనము ఇన్ఫ్రారెడ్ స్పెక్ట్రోస్కోపీ యూస్ చేసే రేంజ్ ఎంత అంటే 4,000 టు 667 సెంటీమీటర్ ఇన్వర్స్. ఎందుకంటే మోస్ట్ ఆఫ్ ద ఆర్గానిక్ కాంపౌండ్స్, ఆర్గానిక్ మాలిక్యూల్స్ అన్నీ 4,000 టు 667 సెంటీమీటర్ ఇన్వర్స్ ఆఫ్ ఇన్ఫ్రారెడ్ రేడియేషన్ అబ్జర్వ్ చేసుకొని దే ఆర్ గోయింగ్ టు వైబ్రేట్. ఓకే, దెన్ there is a condition for infrared spectroscopy that is written in the point number 3. IR spectra is shown by the molecules that have active dipole moments. That means those molecules must have atoms that are having difference in electronegativity. For example, alcohol, amine, carboxylic acid. So in the alcohol, the group OH is having electronegative difference. Oxygen is more electronegative, hydrogen is less electronegative. So this group is polar group. Such a polar groups are going to generate dipole moments. Similarly, in the amines, there will be electronegativity difference between carbon and nitrogen and hydrogen also. In the carboxylic acid, there is electronegativity difference between carbon and oxygen. So these molecules are polar molecules. So they give dipole moments. So these compounds are IR active. Okay. సో ఏ కాంపౌండ్స్లో అయితే డైపోల్ మూమెంట్ ఉంటుందో ఆ కాంపౌండ్స్ మాత్రమే ఐఆర్ స్పెక్ట్రోస్కోపీని ఎగ్జిబిట్ చేస్తాయి. డైపోల్ మూమెంట్ అంటే ఆ మాలిక్యూల్లో ఉండే యాటమ్స్ మధ్య ఎలక్ట్రోనెగటివిటీ డిఫరెన్స్ వల్ల వచ్చే ఒక ప్రాపర్టీయే డైపోల్ మూమెంట్. అంటే ఒక యాటమ్ హై ఎలక్ట్రోనెగటివ్, ఇంకొక యాటమ్ లో ఎలక్ట్రోనెగటివ్ యాటమ్స్ ఉంటే ఆ మాలిక్యూల్ డైపోల్ యాక్టివ్ అని అంటారు. సో డైపోల్ మూమెంట్ యాక్టివ్గా ఉన్న మాలిక్యూల్స్ మాత్రమే ఐఆర్ స్పెక్ట్రోస్కోపీని ఎగ్జిబిట్ చేస్తాయి. ఓకే, right. Then the molecules that do not have dipole moment does not give IR spectra. For example, hydrogen, chlorine, nitrogen. So as you can see, these molecules are made up of same atoms. So 2 hydrogen atoms and 2 chlorine atoms are present in chlorine molecule, and 2 nitrogen atoms are present in nitrogen molecule. So because there is same atoms in the molecules, there is no electronegativity difference, so that there is no question of polarity. So their dipole moment is 0 for hydrogen, chlorine and nitrogen. So they do not give IR spectra. Okay nandi, right. What is IR spectrum? The plot drawn between percentage transmittance and wave number of IR radiation is called as IR spectrum. So IR spectrum looks like this. Any compound, if you record IR spectra for an unknown organic molecule, it will look like this. So there will be plot between wave number and percentage transmittance. Percentage transmittance means the amount of radiation, IR radiation released by the organic molecule after the absorption. It is going to absorb some radiation, it is going to release some other radiations. So that radiation is called as transmitted radiation, and we are going to draw it as percentage transmittance on y-axis. On the x-axis there is wave number. So we are going to send the IR radiations, middle IR radiations from 4000 to 600 centimeter inverse, and the compound is going to absorb the radiations and it is going to vibrate. So these is going to give the absorption bands or absorption peaks. Absorption of IR radiations causes molecular vibrations. We already know that. So మీరు ఆర్గానిక్ మాలిక్యూల్స్కి ఇన్ఫ్రారెడ్ రేడియేషన్స్ మీరు ఇచ్చినట్లయితే, ఆ ఎనర్జీ మీరు ఇచ్చినట్లయితే ఆ ఆర్గానిక్ మాలిక్యూల్స్ వైబ్రేట్ అవుతాయి. ఓకే, సో పర్సంటేజ్ ట్రాన్స్మిటెన్స్కి, వేవ్ నెంబర్కి ఇఫ్ యు ఆర్ గోయింగ్ టు డ్రా ఎ గ్రాఫ్, దట్ ఈస్ కాల్డ్ యాజ్ IR spectrum. Okay, right. Then let us discuss molecular vibrations and principle of IR spectroscopy. So let us assume a molecule as a system of balls and springs. So we know that whenever organic molecule is exposed to infrared radiation, it is going to vibrate. The molecule will going to vibrate. It means the atoms in the molecule is going to vibrate. Okay, so consider, for example, consider that this is a molecule, and we are going to consider in that molecule the balls are atoms and the spring is considered as bond. Okay, so we know that molecules are made up of atoms, and atoms are held together by chemical bonds. Okay, so if you drag the spring, that is going to vibrate. Okay, right. So ikkada manamu molecule ni balls spring ga imagine manam cheskuntunnam. బాల్స్ అన్ని యాటమ్స్గా ఇమాజిన్ చేసుకుందాం, స్ప్రింగ్ని బాండ్గా ఇమాజిన్ చేసుకుందాం. ఇక్కడ ఎలాగైతే నేను ఇక్కడ చూడండి, ఇక్కడ నేను ఈ స్ప్రింగ్ని బాగా స్ట్రెచ్ చేశాను, రైట్. అండ్ ఈ స్ప్రింగ్ని, ఇక్కడ ఉండే ఈ స్ప్రింగ్ని నేను దీన్ని చాలా కంప్రెస్ చేశాను. సిమిలర్గా ఇక్కడ కూడా ఈ రైట్ సైడ్ ఉన్న ఈ స్ప్రింగ్ అంటే బాండ్ బిట్వీన్ ద టూ బాల్స్. ఓకే, సో ఈ స్ప్రింగ్ని బాగా స్ట్రెచ్ చేశాను, ఈ స్ప్రింగ్ని బాగా కంప్రెస్ చేశాను. అంటే టూ యాటమ్స్ మధ్య ఉండే కెమికల్ బాండ్స్ ఇన్ఫ్రారెడ్ రేడియేషన్స్ వల్ల స్ట్రెచ్ అవుతాయి. దీన్నే మనం వైబ్రేషన్ అని అంటాము సింపుల్గా. ఓకే, ద యాటమ్స్ ఇన్ ఎ మాలిక్యూల్ డస్ నాట్ రిమైన్ అట్ ఫిక్స్డ్ పొజిషన్స్. దే యాక్చువల్లీ వైబ్రేట్ front and back about the interatomic distance. So the atoms in a molecule doesn't remain at fixed positions. They are going to vibrate. Okay, at room temperature these molecular vibrations are very low. Ante atoms molecules lunde atoms vibrate avutayi back and forth, munduki venakki chudandi, munduki venakki. ఓకేనా అండి. సో బ్యాక్ అండ్ ఫోర్త్. ఓకే, సో ముందుకి వెనక్కి ఈ బాండ్స్ అనేవి వైబ్రేట్ అవుతూ ఉంటాయి. బట్ అట్ రూమ్ టెంపరేచర్ దీస్ మాలిక్యులర్ వైబ్రేషన్స్ ఆర్ వెరీ లో. సో రూమ్ టెంపరేచర్ దగ్గర యాటమ్స్ మధ్య ఉండే కెమికల్ బాండ్ వైబ్రేషన్ అనేది చాలా తక్కువగా ఉంటుంది. వెన్ ద మాలిక్యులర్ వైబ్రేషన్స్ విల్ బికమ్స్ హయ్యర్ వన్స్ ద మాలిక్యూల్ ఈజ్ ఎక్స్పోజ్డ్ టు IR రేడియేషన్. సో మన గోల్ ఏంటి, ఆర్గానిక్ మాలిక్యూల్ని వైబ్రేషన్ ఎక్కువ చేసి ఆర్గానిక్ కాంపౌండ్ని ఐడెంటిఫై చేయాలి. సో కాబట్టి వీఆర్ గోయింగ్ టు సెండ్ ద IR రేడియేషన్ సో దట్ ద మాలిక్యులర్ వైబ్రేషన్స్ విల్ బికమ్స్ మోర్, దట్ రిజల్ట్స్ ఇన్ identification of that particular organic molecule. Okay, then there are two types of molecular vibrations. Those are Number 1 is stretching vibration, number 2 is bending vibration. So number 1, stretching vibration. So you know that what is stretching? Dragging. We are stretching something, right? We are expanding it. In stretching vibrations, the interatomic distance of a molecule will increases or decreases. You may stretch it or you may compress it. The bond angle remains constant. Okay, so stretching vibrations లో టూ యాటమ్స్ మధ్య ఉండే బాండ్ని మీరు టూ యాటమ్స్ మధ్య ఉండే బాండ్ని మీరు స్ట్రెచ్ చేయండి, ఇంక్రీజ్ చేయండి, లేదు కంప్రెస్ చేయండి, డిక్రీజ్ కూడా అవుతుంది. ఓకే, సో అటువంటి వైబ్రేషన్ ఏంటంటే స్ట్రెచ్చింగ్ వైబ్రేషన్. ఇన్ఫ్రారెడ్ రేడియేషన్కి ఎక్స్పోజ్ చేస్తే స్ట్రెచ్చింగ్ వైబ్రేషన్స్ జరుగుతాయి. స్ట్రెచ్చింగ్ వైబ్రేషన్స్ మనకు 2 టైప్స్గా ఉంటాయి. నెంబర్ 1 సిమెట్రిక్ స్ట్రెచ్చింగ్, నెంబర్ 2 అసిమెట్రిక్ స్ట్రెచ్చింగ్. సిమెట్రిక్ స్ట్రెచ్చింగ్ అంటే సిమిలర్గా ఇక్కడ మీరు చూడొచ్చు. సో దిస్ ఈజ్ సెంట్రల్ యాటమ్ అండ్ దీస్ 2 ఆర్ ద యాటమ్స్. సో ఓవరాల్గా 3 యాటమ్స్ ఉన్నాయి. సెంట్రల్ యాటమ్కి ఈ 2 యాటమ్స్ అవేగా అయినా వెళ్ళిపోతున్నాయి, లేదు దగ్గరగా అయినా వస్తున్నాయి. ఓకేనా, సో దట్ ఈస్ కాల్డ్ యాజ్ సిమెట్రిక్ స్ట్రెచ్చింగ్. ద 2 atoms of a molecule moves in the same direction with respect to central atom of a molecule. సో 2 atoms సేమ్ డైరెక్షన్లో సెంట్రల్ యాటమ్కి దగ్గరగైనా రావచ్చు. ఇక్కడ చూడొచ్చు, మీరు ఇక్కడ చూడొచ్చు, సెంట్రల్ యాటమ్కి దగ్గరగైనా రావచ్చు, లేదు దే ఆర్ గోయింగ్ టు మూవ్ అవే ఫ్రమ్ ద సెంట్రల్ యాటమ్. బోత్ యాటమ్స్ దే మే మూవ్ అవే ఆర్ దే మే కమ్ నియర్ టు ద central atom. So this type of stretching vibration is symmetric stretching. Both are same. Both atoms are moving in the same direction. The stretching is common for both the atoms. And there is second stretching, that is called as asymmetric stretching. In the asymmetric stretching, one atom moves towards the central atom while the other atom moves away from central atom of a molecule. So here you can see, so this is the central atom. So here this atom is moving away and this atom is coming close to the central atom. Or it can be represented as this is the central atom. So this atom is coming near to the central atom and this atom is moving away from the central atom. So this type of stretching is called as asymmetric stretching. So in the symmetric stretching, both the atoms of a molecule moves in the same direction. Either they move away from the central atom or they may come near to the central atom. In the asymmetric stretching, one atom moves away from central atom whereas other atom comes near to the central atom. So that is called as a stretching vibration. Then there is second type of vibration, those are bending vibrations. So in the bending vibrations, the interatomic distance doesn't changes, but the bond angle will changes. So bond angle means this one. Okay, so this is the bond angle, right? Theta, it is represented by theta. So if the bond angle changes but the interatomic distance remains fixed, so that vibration is called as bending vibration. So we have 4 types of bending vibrations. Type 1 is scissoring. In the scissoring vibration, both the atoms moves in opposite direction, just like a scissor. You know that how the scissor is going to close. So scissor is going to close like this. Okay, so both the atoms of a molecule moves in the opposite direction. So that is called as scissoring. And there is second type of vibration, bending vibration, that is called as rocking. In the rocking vibration, both atoms of a molecule moves in same direction. So they are going to move in the same direction, that is called as rocking vibration. So rocking vibration will be represented like this. So this is rocking. Okay, so this is called as rocking vibration. Okay, so this is rocking, right? And there is third type of vibration, that is called as wagging vibration. Both the atoms moves either up or below the plane. So this is the central plane that is passing through the molecule at the center, and both the atoms are going to come near to you or away from you. So here we can represent this like this. So this is wagging vibration. So the wagging will be like this. Okay, so it is coming to you, near to you, or it may go away from you. Okay, so this is minus minus and this is plus plus, plus plus, minus minus, plus plus, minus minus. Okay, so that type of vibration is called as wagging vibration. Okay, right? And there is another vibration that is called as a twisting vibration. In the twisting vibration, one atom moves up the plane while the other atom moves down the plane in the twisting vibration. So this is a type of bending vibration. So in the twisting vibration, so both the atoms are going to twist like this. Okay, this is called as twisting vibration. Okay, so these are the 4 important vibrations, bending vibrations. that is shown by the organic molecules whenever they are exposed to infrared radiations. Okay, then let us see the group frequencies. So we have in this slide we have written and in the another slide I have written about 20 bond vibrations, 20 bond vibrations. Okay, right. So let us see some of them. The carbon hydrogen covalent bond vibration in the aliphatic organic compounds requires the infrared radiation of 2800 to 3000 centimeter inverse, and the aromatic C double bond C vibration bond, the bond between carbon carbon, the double bond, if you are going to vibrate this bond, you need to supply 1460 to 1600 centimeter inverse of energy. Okay, the acetylenic carbon triple bond carbon C triple bond C bond requires 2100 to 2250 amount of value of infrared radiation energy, right. So here we have seen here we have another examples. The aromatic aldehyde C double bond O, so this bond will vibrates at a frequency of 1495 to 1715 centimeter inverse. So and acids, the carboxylic acids, they are going to vibrate at 1650 centimeter inverse. The bond, the amines, the bond between nitrogen and hydrogen, so this bond takes about 3450 uh, amount of infrared radiation. The OH group of primary alcohols requires 3630 amount quantity of infrared radiation. So each bond that is represented here, each bond has its own vibrational frequency. So based on the vibrational frequency, you are going to say that, so for example, if you get an absorption band at 1705 value in the IR spectrum, you are going to say that that compound is aliphatic ketone. So because this frequency is the frequency at which the C double bond O group of aliphatic ketones is going to vibrate. Okay, so IR spectroscopy is very important spectroscopy that gives a very valuable data about the identification of functional groups of the organic compound. So that is the primary importance of IR spectroscopy. So IR spectroscopy clearly gives, it is with IR spectroscopy you can clearly identify the functional groups of organic compounds. Okay, so students, let us see the IR spectrum of ethyl alcohol. You know that CH3 CH2OH ethyl alcohol. So here you can see, so CH3 CH2OH. So ethyl alcohol, this is the plot that is drawn between wave number and percentage transmittance. So you can see a big absorption band here at 3230 to 3500 centimeter inverse. So this absorption is is for the stretching of OH bond. Okay, and for stretching of CH bond, this alcohol, that is ethyl alcohol, is going to take 2950 to 2850 centimeter inverse. Then for CO stretching, for the stretching of the bond between carbon and oxygen, this alcohol is going to take about 1075 to 1350 centimeter inverse. So each bond has its own absorption frequency. Okay, so that is an example that I am going to represent in this slide. I think you got it. Okay, then let us see the applications of IR spectroscopy. What are the applications? So IR spectroscopy is mainly used for identification of organic compounds. So with IR spectroscopy you can identify the functional groups of organic compounds, right. So that is written in as the point number 2. And point number 3 is, with IR spectroscopy you can analyze purity of a test sample, and it is used for determination of the extent of hydrogen bonding in the organic compounds, and for the analysis of dipole moments, bond length and molecular symmetry. You remember that the molecules that are dipole active only shows IR spectra. Okay, for analysis of soil and milk products. Lastly, in industries like pharma, chemical, food, petroleum and research labs. So various industries, various research labs in universities and in private labs, they are going to identify the organic compounds based on the IR spectroscopy. And pharma industry also particularly uses IR spectroscopy because the drugs are having because the drugs are also organic compounds where there is presence of a lot number of different functional groups. So these different functional groups are identified by the IR spectroscopy. Right. Thank you for watching.